Assalamualaikum everyone. Good morning or good afternoon. My name is Muhammad Zaid Haikal bin Muhammad Zainuddin. My ID student 2024 and my supervisor is Samad Zaini bin Khaton. And this is my final year project 1, MEC 299. Our project is titled a study of finite element analysis of a catamaran hull with a moonpool at the payload and operational loading conditions. Our aim is to understand how the Moonpool effect affects the hull structure strength and identify ways to improve the design while maintaining safety and performance. Without waste our time, we move to the next slide. And the background of this project is about catamaran USV. This catamaran of USV is widely used because it provides high stability, good fuel efficiency or battery of electric, and a large deck area. Many USV include a moon pool. There must be a benefit about it, which is an opening in the center of the hull. This allows equipment such as sonar, sensors, or underwater vehicles to be deployed while protecting them from water immersion. Although the moon pool improve and give benefit a lot of benefits to the USV, there will be always disadvantages, such as it may create areas with high stress concentration and reduce the structural stiffness. Therefore, structural optimization is necessary. Now, how we want to overcome this problem? Let's go to the next slide. I will tell you how is it done. Now, the Moonpool will create two major challenges. First is operational necessity, because it is essential for launching and recovering underwater equipment safely. Second, the problem is the structural liability. The opening interrupts the load path of the hull and creates stress concentration around the corner of the moonpool. If the moonpool is not properly designed, it will initiate cracks and eventually reduce the structural life of the vessel. So, the vessel will not hold long enough to adapt with the wave or external force from the lake or river. Now, we will talk about loading conditions. We will talk about it at the next slide. Okay. In this project or research, two main loading conditions are considered. There are two things that we consider in loading conditions. The first is sloshing, where motor where mo- where water move inside the moonpool due to vessel motion. When you as we move, the water get into the moonpool. This produces fluctuating internal pressure. In the moonpool, there is a pressure for the water that inside the moonpool. And the second loading condition is hydrostatic pressure, which means where the water pressure acts vertically on the hull due to immersion. This this loading condition represent realistic operating environment for an unmanned surface vehicle. So let's talk about the mechanic of fracture about catamaran USV. Okay, now we'll talk about force. So force will make stress, and this stress concentration occurs mainly around the moonpool corners. When the loading of force is repeating, it can cause small cracks of from the water, and it will initiate the cracks to the hole at the moonpool from the corner. This crack may propagate under cycling loading, leading to structural failure if left unchecked. So there we start to use the finite element analysis. This analysis or method will help us to predict these high stress regions before physical manufacturing begins. So we will run analysis, finite element analysis, before we took the boat or take the boat to real environment. So we'll test it first in the finite element analysis, such as we can use NCs or others software that have a features that can test the structural strength of material behavior. Now we will move to the now I will tell you about this research objectives. So we move to the next slide to continue our my presentation. Okay. About this project and study, we have two objectives. The first objective is to investigate the stress distribution around the Moonpool under different loading conditions using finite element analysis. That is the first of our objective that we focus on to use the finite element analysis to study our material behavior of the USV catamaran. And the second objective is to evaluate the structural integrity of the hull and identify possible improvement of a safer and more efficient design. The second objective is focused on improvement of the hull of the USV catamaran. Now, I will tell you a short methodology of this project. So, we'll move to the next slide. This research or project methodology consists of four phases. First, we develop the model in MedSurf software, develop the US Catamaran model. Um, when we open the MedSurf, it's already provide the whole design that when we click and when we use the preliminary design, it will come up with a design of a catamaran, and then we change the dimensions to the smaller size or the size that come up from source shape on the requirement. So we follow the dimension, and then it will come out with dimension of USV and a whole design of catamaran. Second, the second phase is we assign material property, match the model, and define the boundary conditions. Our material of this USV catamaran is aluminum alloy. So the third phase is we perform the finite element analysis using operational loading condition in ANSYS software. So we open the ANSYS software, and then we run the finite element analysis in the ANSYS, the computational analysis. The final or the fourth phase is we analyze the simulation results and recommend design improvement based on the stress distribution. So when we get the result, we get the stress distribution of the USV catamaran. From that, we can identify the improvement that we need to the USV catamaran, and we can improve the USV catamaran to be better to avoid cracks or disability of the USV catamaran. So I'm going to tell about the phase one, the modeling. So we move to the next slide. During phase one, the three-dimensional model of the catamaran is fully is constructed. The Moonpool geometry is included accurately because it has a significant effect on the stress distribution. Like just I said, it will have a lot of stress distribution on the corner and in the Moonpool and around the Moonpool. So the model is then prepared for meshing and stimulation to ensure accurate numerical analysis that we call finite element analysis. So we're going to phase 2 and phase 3. The phase 1 is already finished. Now we add phase 2 and phase 3. The simulation is carried out. The hull is subjected to hydrostatic pressure, payload loading, and operational forces. So finite element analysis calculates stress, deformation, and strain throughout the structure. This ANSYS simulation identifies the critical locations where maximum stress occurs, the concentration of the stress. Now we move to result of the analysis of ANSYS using finite element analysis or method. These simulation results are evaluated using the stress concentration factor or SCF. SCF is calculated by dividing the maximum stress near the Moonpool by the nominal Hooke stress. A higher SCF indicates greater risk of crack, initiation, and structural failure, which means when we got SCF value higher, it will be more easier to have cracks at the area. So we will need to improve that area before it deploy to the real world at the river or at the lake. This result help determine whether the current design is safe or requires modification before it's deployed. So now I will tell about my project timeline. This project is planned over 12 weeks. The first week focus on literature reviews and USV modeling of Catamaran. The middle weeks involve the focus more on literature reviews of 15 journal or books. Finally, the last week are dedicated to fully on the simulations and finishing the report, finishing the proposal, to interpret the result, writing the report, and preparing this presentation for my proposal. This schedule ensures the research is completed and systemically. And from that, I hope all of the timeline follows and alhamdulillah, some of them follow and some of them not. There, there will be some of problem and there will be some of not. So that's the timeline of my project. So we go to the next slide. The next slide is the conclusion. Now, the conclusion is this research demonstrates the importance of analyzing multiple structures using finite element analysis. There has a benefits and there has a non-benefits, which means it will contribute to best for the element in the USB catamaran and it will not contribute to the pressure or stress concentration and stress distribution of the water to the moon pool. The findings will help improve the structural safety, optimize materials usage, and support better design decision for unmanned surface vehicle. Also, we can reduce the cost more when we know the problems. Ultimately, this study contributes to developing stronger, safer, and more reliable USV of catamaran hull for future marine operations. That's all from me. Thank you very much for your attentions. I very appreciate it. I'm sorry if there any weakness in my presentation. I hope I will make it better. I hope I will train better. All good things come from Allah and all bad things that all is my mistake. If there are any questions, I will answer it later. And I think that's all from me. Thank you very much again for your attention. And that's all for my project MEC 299 final project 1 about finite element analysis under payload and operational loading. That's all from me. Thank you very much for watching.